All right, lesson 2.3, measures of center. So now that we've looked at different ways to represent graphically some data, specifically we've been looking at like numerical. Now we're going to learn on how we can kind of take those numbers and do some statistics that describe things about my data set. All right, so here's a little review over like the three main measures of central tendency: mean, median, and mode. We literally just did ACT prep in my Algebra 2 class, and we reviewed over statistics stuff, and a lot of this vocab comes up on the ACT. So good review for that as well. Mean is another way to say or calculate your average, right? When I do a top score board for yours this quiz, I gotta do that. When I calculate the average test scores, add up all the test scores of the class, divide by how many students there are, that gives me the average, okay? Same as the mean.
Willis.
Oh, Wesley Winch. Oh. Median is the middle number. And remember, to detect that, like, you often have to like reorder the data set in order. And technically the median doesn't have to be a number in the data set. Like if there's an odd number and it's between 20 and 30, your median could be 25, even though 25 is not in the set, okay? And then mode, M-O, the one that appears the most often. There can be no mode, and there can be more than one mode. Okay, so quick for mean. There's two ways we could calculate mean. Population mean. And I'm just going to kind of show you some symbols that are typically used with these. Which, this is pronounced, it's a Greek symbol. It kind of looks like this. Do you guys know what Greek symbol that is? It's pronounced mu. 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 This Greek symbol means the population mean. So to calculate it, we take the sum of the data entries. Now I'm going to use, remember this sigma notation? So if you see that, that just means sum. Divide it by, and I'm going to do a capital N to represent my number of people in the population. Okay. So we could calculate the population mean or just a sample mean. And sample mean's obviously more common. So sample mean, we use this notation, and it's read as X bar. So if you ever see that like X bar, they're talking about the mean or the average. So obviously, same idea here to calculate the mean. We're going to sum up all the data entry just in our sample and divide by the number of data entries in the sample. I use a lowercase n. Okay, so these are just kind of like some common formulas if you ever see like those symbols being used, what they stand for, but you guys all know how to calculate mean and average. So it's really just a fancy way of saying that. Oh, by the way, I figured out what how you pronounce this word, and it makes sense now. By its modal, because if you have like a histogram, obviously your mode is the one that occurs most often, are these peaks. So if there's two of those, there's two modes by modal. Figure out what that means. Does that make sense? Because these tallest ones are obviously the ones that occur the most often, if you're talking about a frequency, a histogram. So that's where that word comes from. Bi meaning two, modes, most often. Caught that? Had a little, okay, just want to share. Let's try one here. Adults who are being tested for dementia are asked to perform mental tasks such as listing as many animals as they can in 1 minute. Here are the numbers of animals listed in 1 minute by 10 different adults. All right, so my data set is not given to me in order, which technically doesn't matter if I'm calculating the mean. It's what they're asking me to do in letter A. But if I'm asked to find like the median and sometimes the mode, it does help to rewrite the data set like in order. So I'm going to do that. So I look at kind of like my lowest number is 10, 11, and I got 13, 15, 14. Thank you. 14, 15, 17. Do you guys ever have teachers that do something wrong? They're like, I just want to make sure you're paying attention. I hate that. I will never say that. All right. Pet peeve. So there's my data set just rearranged in order from smallest to greatest. So to calculate the mean, let's use the correct notation here of this sample. So it'd be my X bar. I would just add up or sum all of my data entries. So it'd be 10 plus 11 plus 13 plus 14 plus 15 plus 17, 18. And I would divide by what? How many adults are in my sample? 10. Yep. All right, so I did this math for you guys because I know you all know how to use a calculator. 161, obviously you'd add them up first and then divide by 10. So the sample mean ends up being 16.1. So that's the average number of animals that these 10 adults could list. What is the median? The middle number. When I'm doing median, I kind of like just to work my way to the middle. I'm like, all right. And I get here. Yep, so you kind of just have to figure out what's in between these or average them. So like this could be the math you could do if these are not nice, easy whole numbers. But obviously the middle of 15 and 17 would be 16. And here's an example of your median doesn't have to be a value in the set. Okay, this is for part B. The median would be 16. It can be a decimal. In this case, it came out to a nice integer. How many modes does the data set have? 0. There's not even one that's repeated. So what occurs the most often? There's 0 modes. There could be 1. There could be 2. Could be more than 2. Could be none. 0 modes. None are repeated. MO, think most often. Okay. So you guys probably knew how to do that before coming to class today, which is great. That's good review. Here's maybe what's new for you. I don't know. Maybe you have done this. What if I want to do something called like a weighted mean? And a really good example is like calculating like your GPA is actually like a weighted mean because you get different points for letter grades. Okay. So the definition of a weighted mean is the average of a data set whose entries have varying weights. Okay. So let's just say these are your grades from last semester. The grading system assigns points as follows. I forgot to type out the points, so you can just list them here. So for A, you get 4 points. For B, you get 3. For C, you get 2. D is 1, and F is 0. That's for our points. Okay. So you can see how many different credit hours we had for each class, and then what our final grade was. So to calculate your weighted mean, a little like formula you can write down for X bar for this mean is you want to take the sum of the products of the entries and weights. And they're going to divide that by the sum of the weights. Okay. So basically what I have to do here is I have to factor in these like point systems. So let's just kind of go row by row here. So for these 3 credit hours, I got a C, so I would get 2 points for those 3 credit hours. So there's like my product of, you can consider these like your entries. Oh, sorry, your entries. Wait. Okay, I'll explain in a second. So for this one, 3 credit hours at 2 points for those. And we got to sum up all of these. So the next one, For those 4 credit hours, how many points did I get for that one? 2 because it was a C. All right, for my 1 credit hour, I got a D, so I got 1 point for that. For these 3 credit hours, I got an A, so I got 4 points for that. Next one, for these 2 credit hours, I'm just running out of room, so I'm going to come down here. I got a C, so 2 credit hours. And then for these 3 credit hours, I got a B, which is 3 points. So you got to factor in that point system divided by the sum of all of our credit hours. So maybe I can show this. Add up all these. 3 plus 4 plus 1 plus 3 plus 2 plus 3. Okay. I got 2.5. Obviously, you have to like find this first. I think I wrote this right now. Hold on, let me make sure this math is right. Oh, I think I know what I did. Okay. So obviously when you do this math, you have to like find this sum first. So I should have brought my calculator here. We can do it quick. Let's do 3 times 2 plus 4 times 2 plus 1 times 1. I know obviously you can do a lot of this also like in your head, but add up all these first. Ooh, good catch. Good catch. Okay, so I get 40 divided by, in parentheses, this sum. 3 plus 4 plus 1 plus 3 plus 2 plus 3. Oh. Okay, there's your 2.5. This had a weird number. Up to 16. Okay, we're good. So there's an example of just like a weighted mean. We might have to factor in something else, some other like scale when calculating the average. Let's look at how we calculate means on like a frequency distribution and also a histogram. So with these ones, we kind of have like this interval, and then they give us like our frequency. We know how to like read these charts now. You can read through this problem, but basically it's just explaining what you're given in this table. Contemplating using a new, more expensive glue, da-da-da-da-da. The company has tested beams using the new glue, recording for each beam the pressure at which the beam breaks. The data collected are presented in the frequency diagram distribution. Based on the frequency distribution, using the midpoint of each data class, estimate the mean carrying the load of the beams tested. For your intermediate computations, use 4 or more decimal places and round your answer to 1. Okay, so when you're given a frequency distribution to find the mean, if you're given like intervals in the class, which is obviously super common with the frequency distribution, you want to take the sum of the midpoints. I don't know if I want to say sum. Let's just do midpoints. I don't think I love the word sum in there. Midpoints times the frequency and divide it by the sample size. Okay. So I'm just going to off to the right here calculate the midpoints. We know how to do this of each class. So starting with this first class from 860 to 879 to find the midpoint of that class, I would just essentially find like the average of these two. So 860, 879 divided by 2. So it said round this one to use 4 or more decimal places. I think these all came out to nice like halves. So this is 869 and a half. And then you would do the same for all these classes. Calculate the midpoint. Okay. There's all my midpoints for each class. So to find the mean, it's kind of just like a weighted mean here. You're going to take the midpoint times like how many times it occurred, add that all up, divided by our total number of our sample size, which we'll have to sum up that frequency table to figure that. So in here in this first row, I have 4 in my sample with the midpoint of 869.5 plus, add up my next one, I had 7. Obviously, I don't love writing sums this way, but I'm running out of room. 7 at a value of 889 and a half. 8, so this is kind of factoring in like how many actually occurred to get us a better like average here. At the midpoint of 909.5. Next one, 3. 929 and a half. 2. 949 and a half. Okay, so we'd add up all those midpoints times our frequency, divide by the number in our sample. So you could either just like add these together or do what we did in the last one where you're like, okay, 4 plus this total. Round it to 1 decimal place, and you'll get to practice these on ALEKS. Don't worry. 902.8. That's what I got for that. Okay, so when you're given class intervals, calculate the average of the endpoints, which gives you the midpoint, and you gotta factor in the frequency. So it's kind of like an example of a weighted mean. All right, so then a histogram is super similar because a histogram is just a visual graphical representation of the frequency, right? So we do the same thing here. We got to figure out the midpoints. Now these ones are nice. I picked some nice, easy numbers. So let's just down here. What would my midpoint of 500, 700 be? 600. Thanks, Allison. What about 700 and 900? 800. Thanks, Lydia. 800. 900 and 1100. 1,000. Good. 1,200. 1,400. So you're gonna have to calculate the midpoints first, and then to find the mean, we figure out our midpoint and then how many occurred within those classes. So we have 6 for 600. Look at my frequency here. 8 for 800. 7 for 1,000. 4 for 1,200. Plus 2 in my last one of 1,400. Okay. Add that all up. Divide by our total number and our sample size. So 6, my frequencies added up together. 6, 8, 7, 4, and 2. Okay. I got, and again, I kind of rounded this. That's why I'm using the approximate. Rounded to 1 decimal place. 911.1. I didn't read through the problem, but some researchers developing a new intelligence test are trying to decide the maximum time to allow for completion of the test. The researchers have recorded the time for completion of the test for each of 27. Oh, right there, it tells you your total number. 27 participants. So you could check that, though, by adding up all those frequencies, make sure it's 27. The histogram below summarizes the completion time of these 27 participants. Based on the histogram, estimate the mean time for completion in seconds for the participants. So the average time was about 900, a little over, seconds. Okay, last thing that I've talked about is it kind of depends on the shape of our distribution, which of these 3 measures of central tendency will be like the best indicator of the actual like center of our data. All right, so we talked about symmetric means like if I were to split it right down the middle, the same thing's happening to the left as what's going on the right. That's symmetric distribution. Uniform means there's really no change, just kind of like this constant pattern to it, I guess. And then we can have some skewed distribution. So something looks something like this, where it's more heavy, that's called skewed left. Or on this side, it's skewed right. So what I like about this diagram is it kind of shows you like where the mean, median, and mode would all be located. So with this nice uniform and symmetric, the mean, median, and mode are all, well, this one, not necessarily this one, is going to be right like in the middle. Okay? And then you can see as my data like gets skewed, how my mean and my median might not necessarily measure at the same spot. So in that case, which one would be like a better indication of the actual like center? Okay, so that's what we're going to talk about here. The shape of the distribution can help us decide if the median or the mean is a better predictor. The only really time the mode is preferred is when the data is not numerical or like categorical. Or, I mean, it still can be numerical, but if it says like, which of these values occur the most often? So obviously just like kind of look for the keywords that's indicating mode. But usually if it's not numerical, we use the mode to measure the center. So the mean is the best predictor of the middle when there's no like extra super high or super low or like skewed values. So when there's no what we call outliers. So we did talk about this actually recently. An outlier is like a data entry far removed, so either like really high above or really low from where the other entries are. So I often do like competitions with my geometry classes and their class averages. And sometimes all it takes is one student to get a very, very low score to bring down that average, right? Where all the other ones are within the 70 to 90 range and I have 120%, that really does kind of affect the mean. And that would be like an outlier. So when there's no like outliers or if the data is like nice and symmetric, we want to use the mean. If there is a skewed data, then the median is a better measure of the center because it really doesn't change as much. So when there are outliers or skewed data, then we use the median. And there's like some practice problems that I picked out like in ALEKS that'll like give you an outlier and I'll be like, okay, how does this like when it is included in your mean, how did this affect your mean? So you can kind of like visualize this when you do some of those practice problems. And I just have a couple practice ones to do with this idea. All right. So mean, median, or mode. Which one would be best used? There's 9 participants in an experiment, and they had the following reaction time in milliseconds. So looking at my data here, which measure should be used to summarize? Since it's numerical data, we probably don't want to use the mode, but I'm looking at the data here. Does it look like fairly symmetrical? Are there any outliers? What do we think? Looks pretty symmetrical, right? It's not like I have a super high one over here at 30 or super low or super high. So in that case, it's going to be the mean. Should be used to best summarize. There's no outliers. Okay, B. A data set shows the age of each resident at Lakeview Retirement Home. Which measure gives the age shared by most residents? So this one's kind of confusing because the data is still numerical because I'm giving the age, but I see this wordage by most residents. What do you think? The mode. Yep, mode. Which one occurs the most often? 9 members of the dance team each bought new shoes. Here are the prices they paid. All right, look at our data set here. And I see like, whoa, this 24, that's way lower than kind of where the rest of these are at. These all range from like 52 to 62. So this one seems super low. This seems like an outlier that would really affect or really bring down the average. And you can see that it doesn't actually affect the median, right? If we were still to calculate the median, this really low one doesn't change it, although whether that's 51 or 24, I'm still going to get the same median. So in this case, the median's a better indicator of where the middle's going to be. Measure of the center. Okay, I like that example. So kind of one of each. One more with a histogram. To inspect manufacturing processes, companies typically examine samples of parts for deficiencies. One company that measures ballpoint pens selected samples of 1,000 pens on each of the 17 dates. The company recorded for each sample of 1,000 the number of defective pens in the sample, and here's their data. So they listed it out for you right here, and then they also graphed it for you on this frequency histogram. Which measures, I'm on A now, which measures of central tendency do not exist for this data set? Anytime you're given numerical data, there's always going to be a mean and a median. Always. You can always calculate it. So for numerical data, these always exist. Doesn't matter what the numbers are. We can always calculate the average. We can always find the middle, even if it's a non-number. There is a chance where there could be no mode, right? But looking here, looking at the list, because here they obviously let class interval it. Looking at the list, what is the mode? There's 2 of them, yep. What's one of them? What numbers occur the most often?
1 and 5.
1 and 5. So this one has 2 modes. So in this example, all measures would exist. Okay. B says, suppose that the measurement 17, the largest measurement in the data set, was replaced with the 41. Okay, let's assume that. Or let's pretend. Which measures of central tendency would be affected? Austin? The mean. Would the median be affected? No, because if I still to go in and find my middle number, doesn't really matter what my highest one is. The median would stay the same. Would the mode change? Nope, just the mean would change. By adding in that higher, it is going to bring up my average. That happened with my geometry class one time. My 7th hour was like 0.2% away from beating 8th hour, and I had this kid making up his test, and I was like, no pressure, but you need like 100% to bring up this class average to beat 8th hour, and he did it. Ooh. All right, last one, and we'll call it a day. Suppose that, starting with the original data set, the largest measurement was removed. Okay, so we're just getting rid of this one altogether. Which measures of central tendency would be changed? Well, definitely the mean. Would the median change? Kind of depends on my list here. Oops. Okay, let's pretend that number was still in our set. We didn't actually calculate the median is. Okay, the median was 5. Now, if I remove that, does that change my median? No, it doesn't. And that definitely doesn't change my mode. Okay, you'll see my median is still 5, so it only affected my mean.